for want of time, I think we have to discuss immediately about the artificial intelligence, how it is really helping shaping the AM. Because all this, especially the QF, the quality framework standards, I think needs a lot of detailing, uh, sector-wise, requirement-wise, components, application-wise. I think all that deep understanding is very much required. This is a hint or an address towards exploring further details. I think that's yeah, that's a point which I can say now. So, um, would you um, would you like to share some thoughts or what's happening AI with AM development?
Absolutely. Because if you don't do that, I think I don't do justice to what I'm talking about, because the AI is everywhere, and AI is there in the manufacturing as well. I'm just leaving this part because I already mentioned it's a different pathways to certifying a part. But when it so these are some of the qualification approaches, meaning we are not moving from conventional to advanced levels. We use process qualification using NDE and model based. These are all now enabled by AI.
Yeah.
Getting into the status of AI, so what are you seeing in the top is our current workflow,
Okay.
and how the current workflow is getting impacted by AI is that when it comes to design, we already have generative design and topology optimization softwares and things like that. But once you integrate that with specific AM constraints, then that will be more impactful. And these large language models in additive manufacturing, we're not talking about large language models, but still that can help at least in one phase where we can compare or improve our design capabilities. So that's an area where AI will be helping the new additive manufacturing workflow, then followed with the machine learning for parameter optimization. And this one would be very much helpful when you work with, let's say, high entropy alloys, where there's a large space when it comes to the combination of alloying elements. So you cannot do iterative processes or repeated open building and testing and see or optimize the parameters. So that's where AI can come in and help in predicting the parameter sets for all those different variety of alloys. And the third one, now we said we do the build. So when you do the build, we need to come up with a closed loop control. So for the closed loop control, as I said before, we have a lot of sensors now. So the data that we have collected from these sensors can be used by an AI agent and help the machine to calibrate or control the process in real time. Similarly, when it comes to post-processing, it can help to predict whether you really require an hit, or whether or which kind of thermal processing that you should go with, and what level of machining that you can go with. All these things can be predicted if you supplied or if you teach or teach the model with the right methodologies. And the most important one is the inspection. So we can teach the AI model with all possible build artifacts or all possible defect types, so that once it find it, it can come up with a no go statement saying that, okay, this particular one got these defects, and this percentage is above the threshold, so this is not a part that can be used. So we realize the importance of AI in not in additive, in advanced manufacturing, and the AS team is now getting into that space in a more comprehensive way, where we just started a new committee on AI in manufacturing systems. It's called ASTM F450, F50. And the inaugural meeting of this particular committee is happening on June 3rd and 4th, this next month, 3rd and 4th in Dallas. And along with that, we also have a conference in AI in manufacturing systems workshop. And we also did similar workshops that emphasize the importance of additive manufacturing and artificial intelligence in additive manufacturing, as well as in autonomous production. Not just us, there are so many other organizations like NIST in the US. They're all now coming up with different programs to support how AI can be implemented in real-time production. So when I say you implement AI in real-time production, you need some kind of shared definitions. You need common expectations. There should be data frameworks that should be interoperable, because data is the key for AI. If you can't, if there is no reliable data, AI cannot give you anything. So it's more like, what you give, it process that and provide you the output. If you provided some rubbish, then the output is also rubbish. So we have to generate, we have to have the right data that need to be supplied. So there should be standard that manages those, and also consensus on how this AI system should be evaluated and tested in production. So considering these things, we have started this committee on AI, that is ASTM F50 in manufacturing systems. So a lot of things happening in this field as well on manufacturing. It is not ChatGPT, or it's not all different AI things that we have seen, but for manufacturing it is entirely different. We use it for completely different stuff that we are normally using with ChatGPT or things like that.
Okay, so I think soon the world will have a slogan like AI for AM and AM for AI, because many, even the tiny parts are going to be built by through AM, which is going to be part of the data center, semiconductors, processors, cooling.
Yes.
Okay, so I think AM is going to really play a vital role in enhancing the AI capability, and AI also going to assist AM in terms of equality. So it is going to be a mutual, a symbiotic association.
Absolutely.
AI for AM and AM for AI. Probably that
And I
would
would
be a
say it's not just for AM. We are now expanding it towards advanced manufacturing. So
excellent.
getting into robotics, automation, semicons, and all those different things.
Yeah. I think that's very interesting development. So I think we didn't realize that, okay, we have crossed almost 1 hour time, because the topics and the discussions were very interesting, very relevant, and addressing many curiosity, and many of the industry problems or engineering problems we normally come across in various applications, whether it is automotive, manufacturing, aerospace, defense, medical. So various aspects where we come across, and in fact there are a lot we could have touched upon the medical itself, where the dental related area, implants, prosthetics, implants, those are having a wide applications, and many are really interested. I think I strongly feel we should have a sequel for the session, where we'll pick out a few vital industry sectors, and we can do a deep dive into that. I think that will be a very beneficial for many who are in the engineering fraternity and also the industry area. So I think that would be my request to continue. Stay tuned with the with the forum to have a sequel, to have a continuity of our session. Okay, so that's my request with
Absolutely,
Dr.
yeah.
Khalid. Dr. Khalid.
Absolutely. Obviously, today what we discuss is quite high level, and we can
Yeah,
even pick one industry sector and see, how we can uh, go deep into it and understand, what is there on all these different topics that we discussed so far.
exactly. So with this, I think we were keeping some time for the Q&A, but very interestingly, we have been receiving very creative comments and queries throughout our discussion itself, and almost all the points which we have received, we could touch upon the presentation itself and during the discussion itself. So I think it's okay. Uh, I think we don't have to spare more time for the Q&A, because we have been receiving the chat on the chat. We have been discussing points which were uh, commented by our
And
respective.
if anyone is interested for any additional stuff, you can also write to us. I provide my email here.
Sure. Please go ahead. please feel free, and I'll also link it. Anyway, your profile is also tagged in the session, so anybody who wanted to have a direct message or a connect with Dr. Khalid, he's a director of training and certification with